Hi, welcome to CDA 5220, Foundations of Secure Execution Environment. I'll briefly introduce the course. First, my name is Jan Solihin. I'm a professor in computer science and also the director of the Cybersecurity and Privacy Research cluster at UCF. A little bit about me. I have been a professor for 23 years. I got my PhD from UIUC in 2002. I spent 16 years as a professor in NC State University, 2.5 years as a program director for the National Science Foundation, managing secure and trustworthy cyberspace, which is their flagship computer security program. Then I joined UCF in 2018 to lead the cybersecurity and privacy cluster. So let's talk a little bit about what is secure execution environment. So prior to about maybe 10 years or so ago, people care a lot about the security of their computer code or their application code. Okay? And then they assume that the environment in which the application runs can be trusted or secure. However, this changed with the introduction of cloud computing, in which the application owner or the users no longer have control over the environment. When they run their application in a cloud computing server, the cloud computing provider is the one that controls the environment in which the application runs. Okay? So what is this environment for the application to run? Okay? It includes anything that is provisioned to help the application to run in software as well as in hardware as well as the stuff. This includes, for example, libraries, operating systems, hypervisor in software, but in hardware as well, the microprocessor, the entirety of the server infrastructure, and also the staff member who oversee or who manages this infrastructure. Okay? So the reason for why there is a concern about the execution environment security is because the cloud computing provider want to provide assurance to the clients that if your applications run on our infrastructure, you can be sure or you can be certain that your applications will have certain properties guaranteed, like the confidentiality, integrity, etc. At the same time, the reason for cloud computing to be quite successful is because the same hardware resources are shared by many different clients. Okay. Now, with this, then there is increasing security concerns, where if I am a client of cloud computing service, I have worries that whether other clients, other applications, or other operating systems, etc., can learn something about my application, okay, in terms of confidentiality, or maybe can affect the outcome of my application, okay, which deals with the integrity of my application. Okay, so because of that, then secure execution environment becomes an important research, and now today it becomes an important part of the security infrastructure in the cloud. Okay, let's talk a little bit about what it is not about. Okay, secure execution environment, it does not concern with the code, the vulnerabilities of the application itself or the code itself. Okay, so for that there are other courses and other concepts that apply. So this secure execution environment only concerns with the vulnerabilities of the environment in which the application runs. Okay? And as I mentioned earlier, environment includes operating system, device driver, hypervisor, and the hardware, processor, memory, and the stuff. So these are the environment in which the application runs. Secure execution environment is a relatively new topic. So I would say it's less than 20 years old, and there are very few universities teaching secure execution environment as a separate course. But UCF is one of them. Okay, so in UCF, we have the foresight to know that this is an important topic, and students need to know this. Okay. Now let's talk a little bit about what is the root of trust with secure execution environment. Now, given that environments can encompass a lot of things, at some point, the client of, let's say, cloud computing needs to trust something, right? Even the cloud computing provider also needs to trust something. Ideally, we want the trust to something that we trust, which is called the root of trust, to be as small as possible. Okay. At the same time, it has to be quite practical. Okay. Therefore, the root of trust tends to be, and it's not always the case, but tends to be, goes down all the way to the processor itself. Okay, so to the CPU or the processor or the hardware system. In this case, the root of trust is the processor that provides environment in which the application does not need to trust the rest of the system applications, including operating system, driver, hypervisor, etc. So even though there may be vulnerabilities affecting the operating system, hypervisor, device drivers, etc., the hardware, the processor, provides some kind of guarantee to the application, to the client, to know that certain properties will be met. Okay? And these properties may be confidentiality, integrity. Now there is another aspect, which is availability. Now availability is usually not provided by in secure execution environment. The reason is because it's very difficult to do that. Okay, the operating system or system software in general, the role of this software is to manage the hardware resources. Okay? Because of that, providing availability is fundamentally antithesis to trusting the system software to manage resources. Because by managing resources, they can take away resources, shut down resources, remove resources from the application. Therefore, secure execution environment focuses on the confidentiality and integrity, but not on availability. Okay. And this course complements other courses at UCF, especially for the Master in Cybersecurity and Privacy, because this deals with the security of the environment, whereas other courses may deal with how to write application code that is secure, etc. So this kind of complements each other. However, it relies on the foundations of computer security and privacy that are needed to ensure the properties are met. Now this course, because of the root of trust being in hardware, this course is also related to other computer architecture courses, such as CDA 5106, Advanced Computer Architecture, CDA 6107, Parallel Computer Architecture, etc. So, students enroll in this course need to be aware of some of the computer architecture techniques from those courses. In fact, I assume certain prior knowledge that you have, even though I will cover concepts in this semester that deals with some of this, but it will be kind of like an overview rather than covering the fundamentals. So you are expected to know these fundamentals, and then I will give you an overview as a refresher. Let me just close to motivate you that this is a really new area at the intersection of software and hardware. It's an exciting area, only recently recognized in its importance, but its importance is growing leaps and bounds every year. And by learning this course, you will learn something new. Hopefully, it gives you the edge in the knowledge when you get your degree or when you complete this course. So I'm looking forward to interacting with you over the course of the semester. Please make sure that you go to the web course and look at the modules that I introduced there, all the materials. Until next time.